Good afternoon. My name is Louis Mantini, and I am going to moderate this webinar for the Society of Wetland Scientists. I'd like to welcome you all here today, and we have an exciting webinar brought to us by on the subject of evaluation of soil respiration rates across a range of well pad peatland restoration treatments in the Alberta oil sands regions. Before we get started, I would like to draw your attention to the control panel on the right-hand side of your screen. There will be several, or a few of the, I guess, the arrows that you can choose to collapse or expand. And in particular, you'll be interested in the questions and the one arrow that will provide you access to the handouts for this particular presentation. Everybody's going to be on mute as well. I'd also like to remind those that are unaware that if you are a professional wetland scientist, you can obtain credits for certification, and you'll be notified after the webinar to sign up or to actually request a certificate of completion for the 0.06 equivalent semester hours as shown on the screen here. This is also available to non-members at a fee. So today we have two presenters, and they're from two different and distant locations on the globe. And first of all, I'd like to introduce Arohi Dixit, who is currently enrolled and working towards her PhD at Jawaharlal Nehru University in New Delhi, India, where she is a research fellow in the School of Environmental Sciences. Arohi's interests include urban wetland water quality, wetland carbon and methane fluxes, water and sediment nutrient studies, stable isotopic systematics, and the use of isotopes to trace pollution. This presentation highlights her keen interests in identifying effective wetland restoration and management strategies. Arohi earned her Master of Philosophy degree characterizing heavy metals in urban soils while exploring geochemistry in an urban landscape of changing land use. Currently, she is working on several wetlands in Gurgaon, one of the highly developed cities of India, for water and sediment quality, along with nutrient dynamics. She'll be joined also by Dr. Tariq Munir, who is currently a professor at both the University of Calgary and St. Mary's University in Alberta, Canada. He earned his PhD at the University of Calgary by evaluating modeling the impacts of industrial disturbance or climate change on wetlands and the impacts of greenhouse gas fluxes on peatlands. Dr. Munir is also an oil and gas industry consultant, and this presentation in part relates to his experiences in wetland protection and regulation as a wetland engineer with oil sands development and research. Two of his major projects in this research have been remote monitoring of restored or reclaimed peatlands from well pads and treatment function modeling of wetlands receiving mine wastewater. And with that, I'd like to move forward, and we'll have Arohi begin the presentation.
Yeah. Hello. Thank you, Tony.
Thank you.
Hello, everyone. This is Arohi Dixit, and I am working as a PhD student in Delhi. Today, I'm excited to talk to you about my research that I carried out in University of Calgary and NATE, Boreal Research Institute, Peace River, as a part of SWS Wetland Ambassador Graduate Research Fellowship Program. First of all, I would like to thank SWS for providing me such a beautiful opportunity that helped me in exploring a different culture of research in a different field and in a very different climatic zone. Also, during these 3 months summer project, I received mentorship from some eminent people working in this area like Dr. Tariq Munir, Dr. Binzu, and Dr. Maria, which expanded my horizons of knowledge and research networks. So thank you all of them, and thank you for listening to me. Now coming to the work, my talk today will be focused on soil respiration rates across well-packed peatland restoration treatments in the Alberta oil sands region. Now before we proceed to the actual experiment, let's get introduced to these spatial wetlands. Peatlands are the peat accumulating wetlands displaying an accumulated peat layer equal to or higher than 40 cm as described by National Wetlands Working Group. They are the largest natural terrestrial carbon store and thus are the most efficient carbon sink on the planet when undisturbed. These special wetlands cover only about 3% of global land area but hold around 33% of the global carbon stocks. Like any other wetland system, they mitigate floods, filter waters, and sustains biodiversity, accumulate carbon, and they also play an important role in climate change. These valuable wetlands are characterized by slow respiration rates of decomposition, which leads to a long-term accumulation of organic material that we know as peat. They are typically classified based on three criteria, that is chemistry, hydrology, and vegetation, and are divided into two main groups. These are bogs and fens. What are these bogs and fens? So let me introduce you with these two terms. The two very important members of the plant community describing majority of peatlands. Talking about bogs, they are the ambrogenous ecosystems with their pH range falling around 3 to 4, and they receive their water from precipitation only, and that's the peculiar difference between a bog and a fen. The water table is typically found at 40 to 60 centimeters below ground with low seasonal variation, and these classes are poor in nutrients. While opposite to bog, fens are geogenous ecosystems where the pH ranges between 4 to 8. The mineral content is higher in fen as they receive water inputs from precipitation as well as from runoffs like groundwater as well as from the surface water. Fens are amongst the most diverse ecosystems in terms of flora in the boreal zone. Now we have a look at extent of peatlands in Alberta. We found 78% area of the province falls in peatland zone, while the rest found in the mineral soil wetlands. Also, out of the total wetland area, province around 90% are the peatlands. I mean, this area you can see the upper one. The main land use type includes forestry, oil and gas, oil sands, and coal. And this is where this experiment or the study was focused. Now, oil sands mining out of these has emerged out as the biggest culprit for disturbance of these Alberta peatlands. The three Alberta oil sand deposits are mainly located in the boreal region, and altogether they cover an important portion of the landscape, somewhere around here and somewhere around here, wherever study was focused, and we choose our sites. The disturbances related to these mining include the construction of well pads and the connected linear features in water. These features include like construction of pipelines, exploration of seismic lines, roads for accessing these well paths. So these are the main disturbances that are related to these oil sands mining. Now reintroducing peatland vegetation on these decommissioned well sites is an important step towards peatland restoration. Now the next question arises, why peatland, why restoration? As disturbances in these wetlands may lead to loss of various ecosystem functions and services, and their inclination towards carbon source from sinks. So there is an urgent need to bring these wetlands to their original status. Here, restoration techniques can work as a significant emission reduction tool in a very cost-effective manner. Now, for this restoration, which is mainly uh, uh, related to loss of ecosystem function and services, on this part where our study was mainly focused. So there are a large number of techniques which are adopted as a part of restoration program, like different plant material introduction, removal of paths and compacted well sites, elevation and mixing, and so on. So how these peatland restoration techniques is related to respiration, why soil respiration is used as one of the methods. In this study, I cannot see, oh yeah, here. So how soil respiration and peat restoration was connected. So comparing the CO2 flux rates of the restored ecosystem with that of the undisturbed one can be an effective tool in selective restoration treatments for bringing these ecosystems to original level. And these methods of soil respiration, comparing with the different undisturbed sites, was the one technique to evaluate how much our sites had restored. They are showing the ecosystem restoration. What was there over this whole study is mainly focused. Now for the next presentation, I will switch to Dr. Tare. Hello, Dr. Tare.
Yeah, I'm here. Can I go to the next slide, please?
Yes.
Hello, everybody. I am Carex from Calgary, Alberta. And I would like to say thank you to Tony, Luis, Michelle, and Kim for working out with us for so many days, and especially reminding us for the webinar every other day. So, and also thanks for all the audience here for providing us opportunity to explain our research on this valuable forum of Society of Wetland Scientists. So let's go to the experiment. What is this experiment and where it was conducted? Well, I will give you a little overview, just a quick one. Actually, this is a lab experiment. It was conducted in the laboratories, although the core soil samples, they were collected from 3 different well paths in the northern Alberta. And then they were brought into the 2 different laboratories, one after the other. The first laboratory we brought it to is the Boreal Research Institute laboratory, located in the Peace River with the Northern Alberta Institute of Technology, where the well pad restoration program is led and headed by Dr. Pinshu. The second laboratory we carried out our experimentation is at the Department of Geography, University of Calgary in Alberta. Can you go to the next slide, please? So this experiment was conducted in the laboratories while the field samples were collected in the northern Alberta. Next slide, please. Let's go to the actual location where we collected the samples from. So on the left side, if we look at the Alberta map, in the northern part, there are two pads, IPAD and SKEG. So IPAD and SKEG, they are the decommissioned and then the restored well pads. They are about 7 kilometers apart. While the third restored well pad, which is called H38, which we can see towards the southeastern of these two well pads. So H38 is about 700 kilometers distant from these, the first two well pads. Okay, next, please. I would like to explain a little bit about these three research sites. I would say also, sometime I would name it the restored well pads. So the first well pad I mentioned was a SKEG. SKEG, the name essentially comes from muscat, means an acidic mire. Actually, it was a treed bog, and it is located in the northern part of Alberta in the Peace River oil sands region. This well pad was constructed in 1987, and for the construction, a 1.5 meter thick clay fill was used. And this pad was underlain by a geotextile liner. Now, this pad wasn't extracted for the bitumen for some reason. But anyway, since the regulatory criteria in Alberta is stringent, and it requires or desires to all the disturbed wetlands and the peatlands, especially those decommissioned well pads, they should be brought back, returned to the original peatland or the wetland conditions. So in order to meet the criteria and to see which of the treatment would be better than the others, about a 30-meter wide strip of the clay fill that was removed. It was completely removed. And then the Southern Illinois University researchers, they were allowed to conduct the vegetation experiments on this 30-meter wide strip, which was a restored wetland now. And they planted 3 types of species, including shrub, sedges, and some tree species. And now this need to keep in mind that the reclaimed 30-meter wide strip, that was uneven. It was higher on the southern side while lower on the northern side. So I would call the species on the southern side as dry plants or the dry vegetation, while on the northern side it was wetter. So I would call it a wetter vegetation. Next. Second research site, or the restored oil well pad, that is still located in the Peace River oil sands region. And the name IPAD comes from inversion pad, where either the clay was inverted or the peat was inverted, or it was a mixed inversion. This is a fan different from the SKEG that I explained earlier. This is a fen peatland, and it was constructed 2006 and reclaimed in 2011. Similar to the SKEG, it was constructed using a 1.5 meter thick clay with a geotextile liner underneath. So here, the regulatory criteria, as I earlier explained, required to reclaim and restore this well pad to the original fen or the natural fen conditions or the trajectory. So in order to do that and to test and take advantage and test which treatment would be better than the others for bringing this decommissioned well pad to the original conditions of the wetland. This well pad was split into 3 sections. The first section, we call it as a clay inversion, where all the clay that was removed and put back to the borrow pit, while the peatland surface wasn't still at equal height that of the natural surroundings. So that's why the peat was pseudo decompacted using various equipments in order to bring the surface up a little bit. The second treatment was created was a peat inversion, where some clay from the pad was removed and put to the borrow pit, while the rest of the pad that was placed underneath the peat surface, since the peat surface was really thin. So in this way, this was a peat inversion. And the third treatment was a mixed inversion, where while removing this clay fill, it was mixed up with the peat surface, and therefore it was left as such in order to see if this would be better than other treatments in order to bring the decommissioned site to the original conditions. Next, please. A third research site is an H38 site. It's a different oil sands region. That's a coal lake oil sands region in the northern Alberta. It's a tree-rich fen, and different from the other 2 pads, this pad was extracted for the bitumen. And this, according to the regulation, this pad was reclaimed or restored to the peatland trajectory, and this well pad was split into 2 major parts. One part, the clay fill was completely removed, and the other part, the clay part was partially removed. Next, please. And I would like to explain the treatments on these 3 sites here. Next, please. So on the SKEG, what are the treatments we created here? Remember, the SKEG was a bog, and here the southern side was higher than the northern side of the strip that was reclaimed. So on the southern part, 2 treatments were created with respect to the vegetation there. One of them was dry willow with the dry willow with the DW acronym, and the dry Carex with the DC acronym. So these are the 2 treatments on the southern side. On the northern side, they were wet treatments, so they were called as a wet Carex and wet willow. And the rest of the 2 treatments, they were a natural hollow and a natural hummock in the natural surroundings of this restored well pad. Next, please. So in the SKEG, there were 6 treatments in total, including the 2 natural ones and the 4 we created. Here at the iPad, there are only 3 treatments. We don't have here the natural surrounding, and it was allowed to be compared with the other natural surroundings in the area. Here are the 3 treatments that were created on this iPad, or the inversion pad. I earlier explained a little bit. Those were the clay inversion, where all the clay was removed and the leftover peat was fluffed. And the second was peat inversion, where the well pad was placed underneath the peat. It was a peat. And the third was a mixed inversion, where the peat and the clay was kind of mixed in order to allow to to have some microform just like that of the hummocks. So it was a pseudo-like kind of a treatment. Next, please. And the rest, the last H38 third side, total of 8 treatments. 2 treatments on the completely removed pad. 1 treatment where there was a vegetation on the wet surface, while the other treatment was there was a ponding or the open water. Acronym will be used as a completely removed CPW, and for the vegetation CPV. So then the 2 treatments were moss and equisetum on the partially removed pad. And then the next 2 treatments were sedgy and non-sedgy on the partially removed pad. So on the partially removed pad, there were a total of 4 treatments, but on the full removed pad, there was 2 treatments. And it makes 6 treatments, and the rest 2 treatments, there were natural fen, hummock, and natural hollow in the surrounding natural fen. Next, please. So in total, there were a total of 17 treatments for this lab experiment, and where the samples were collected from the field. Now I would invite Rohi to please explain on the sampling method she used, or analysis method she used in the laboratory. Thank you.
Thank you, Dr. Bhai. Now come to the sampling part of this experiment. I think sampling part is one of the most important part of any experiment being done. It is the initial stage where, if not done properly, the errors can be done. For this experiment, there were 3 sites were selected as explained by Dr. Tariq. From each site and from each treatment, 3 replicates were selected. From each replication, a plot area of 15 centimeter square within each replication was randomly selected, and the upper 1 centimeter was removed. Peat cores were collected from the top 15 centimeter layer, and for every replication, 2 cores were collected for different parameter analysis, one for the bulk density and the other core for the other analysis. In such a way, a total number of 51 samples were collected for carrying out this study for pH, EC, bulk density, dissolved organic carbon, and loss on ignition, and the soil respiration. Now these were the parameters that were studied. pH is one of the most important parameter as it directly affects the decomposition rate and thus the soil respiration. Samples were analyzed in lab using a benchtop pH EC meter for this analysis, and 1:3 soil water method was used. Come to bulk density. For this analysis, a simple method for core was collected. Its dimensions were recorded, length and the diameter. These cores were then transferred to a wet aluminum pan and dried at 105 degrees Celsius in an oven. Then the bulk density was calculated from the total weight of the pan before and after drying. Then comes to loss on ignition method. For this analysis, a 2-step drying method was used. Around 2 gram sample was taken in a silica crucible. In one step, they were dried at 100 degrees Celsius for around 1 hour, and in the next step, they were dried at 550 degrees Celsius for 2.5 hours using a muffled furnace. From the pre-ignition, and post-ignition weights, the LOI was calculated. The next parameter analyzed was dissolved organic carbon. For this analysis, each of the collected pore water DOC samples was passed through a 0.4 micron glass fiber filter. The filter samples were then transported to the lab and stored at 4 degrees Celsius. Few samples were selected for TOC analysis and diluted to 1:10. These samples were then acidified using concentrated STL and analyzed for TOC concentration using the TOC analyzer with the help of NPOC method, that is non-purgeable organic carbon method. All the samples, those were undiluted, were analyzed for DOC using a Perkin-Elmer-Lambda spectrophotometer for absorbances at different wavelength, that is 250 nanometer, 254 nanometer, 365 nanometer, 465 nanometer, and 665 nanometer wavelengths. Among all the evaluated wavelengths, tested for correlation to the measured dissolved organic carbon concentration, 254 nanometer was chosen as it best explains the variation in dissolved organic carbon concentration. Other observances were used to calculate SUV-A 254 and some other absorbance ratios, that is E2 by E3 and E4 by E6. These were also determined for the DOC chemistry analysis according to use of Khadka et al. 2016. Now come to respiration rate measurement. For this measurement, an incubation jar method was used. Respiration rates were measured using infrared gas analyzer (IRGA). For the analysis, a known amount of sample was taken in an incubation jar having septum lids. The weight and the volume was predetermined, and these jars were then sealed for 10 minutes and 2 readings were taken. One immediately after the sealing and the other after 10 minutes. Now using a syringe, we extracted around 5 ml of CO2 sample from the headspace and injected it into the agar. The instrument was already calibrated and stabilized. The experiment was repeated every third day and 9 sets of such repeats were obtained. During the whole experiment, it was kept in mind that gravimetric water was maintained. Now come to the next slide. Here, this video shows how this using the IRGA soil respiration rates were measured. Around 5 ml of CO2 was taken from the headspace with complete mixing. This was done just to mix the gas present inside this incubation jar. Then the gas was inserted inside the agar. This is the agar, and then readings were taken. For every time, readings were repeated. I hope that's it. Now for result and discussion part, this is to Dr. Tariq.
Okay, thank you again, Rohi. Before I would present the results and discuss a little bit on it, we need to keep in mind that as the Alberta regulations for the environmental restoration, they are stringent, and they desire the disturbed ecosystems, especially those of the wetlands or the peatlands, be returned to the original peatland trajectories. So there should be some criteria which would confirm or indicate that the return to the natural ecosystem trajectory was successful. So what are the indicators we choose for confirming the success of restoration? Mainly, there are three of them. Like, first is the gross ecosystem productivity, or the biomass and the soil, and then the second, soil respiration rate, and the third, dissolved organic carbon. Actually, pore water dissolved organic carbon, which I would say DOC. So there could be several more. However, usually these are monitored in order to confirm the success of restoration. Next, please. So the first criteria for monitoring if the restoration was successful is the soil respiration. Next, please. First, I will present the soil respiration rates across the three well pads, the stored well pads we presented here, and we'll also present the respiration rates at the well pad treatments, and then if they were different or not from the natural surrounding. So first, I would take the individual well pad. The first well pad is the SKEG. At the SKEG well pad, the treatments, the four treatments, they were not different from the natural surroundings. As the p-value shows on the bottom is 0.32, and these treatments, when they are not different from the surroundings, it means that the restored ecosystem is coming back to the original peatland trajectory, or the original bog trajectory. Next, please. Here, I think the legend is a little bit of a smaller font, so we need to make a little bit larger. I notice here. Then the second well pad is iPad. Same thing like SKEG. The respiration rates between the treatments are not different. With the p-value is 0.16. But anyway, the highest respiration rates we notice here with the clay inversion. I mean iPad, and the CI clay inversion is respiring at the highest rate. Next, please. So third is the H38. Here we see the treatments are different from the natural surroundings with a p-value of 0.05. So in the next graph, we also will see which treatments are different from the surrounding hummock and hollow mean, and which are not. But here we can see the hummock, the natural hummock HHUM, that is respiring at the highest rate. Means there are a lot of accumulation, because this is the natural one. So a lot of forest floor accumulation on top of top of the soil, and also the root litter and the roots biomass, which is respiring at the highest rate. Next, please. Oh, this graph actually presents all the three well pads and compiled in one graph. So here we see the SKEG, iPad, and H38. Starting from the SKEG, if we notice that on the y-axis there is the average soil respiration rate, and on the x-axis there are the different treatments. We have compared the treatments at each well pad with its natural surrounding. That natural surrounding is the mean of hummock and hollow respiration rate. So we see that in case of SKEG, all the individual treatments, they are not different from the natural surrounding. And the iPad between the treatments, they are not different as well. But in the case of H38, we see 4 out of the 6 treatments on the right side. 4 out of the 6 treatments, they are different. But 2 treatments, which are partial pad removal with equisetum vegetation and the non-sedgy vegetation, they are not different from the natural surrounding. So it means these equisetum vegetation and the non-sedgy vegetation could be shrubs. They are accumulating the root litter and sun biomass there, which is could be the reason, because they are respiring at a higher rate. So next, please. So the second section I will describe as an indicator of the return of the restored well pad ecosystem to the natural trajectory. That ecosystem function is the dissolved organic carbon. Actually, it is a dissolved organic carbon that is present in the pore water of the soil. Next, please. So here, for the DOC part, I have split this DOC into two sections. First section is the DOC concentration, and the second section is the DOC quality. So I will take them one by one. First is the DOC concentration on the y-axis. On the x-axis is still the treatments and their natural hummock and hollow adjacent to the treatments. In case of the natural surrounding, we are taking the mean of the hummock and hollow in our case, because there are no hummock and hollow on the well pads. So we have to take the mean here. So in case of SKEG, we see the concentration of pore water DOC is really low in the treatments. The individual treatments are compared with the natural control. So wet Carex, wet willow, dry Carex, and dry willow, they are all different. If we remember, in case of respiration, that was otherwise. I mean, the SKEG, the treatments were not different from the natural surroundings. In case of iPad, it is the same, like they are not different from each other. But in case of the H38 well pad, here we see the peatland treatments, the treatments we created. There were a total of 6 treatments we created here, and none of them is different from the natural surrounding here. So this is the opposite of the soil respiration rate at the H38 we notice here, where the 4 of the treatments, they were different from the natural surrounding. So now I would like to go. It means what that mean is. It means the vegetation here at H38 is releasing fresh substrate in the pore water, and that is which is comparable concentration to the natural surroundings. Next, please, if we go to the DOC quality. So now that was a DOC concentration, but now how we analyze this concentration for the quality part. So the DOC quality is actually evaluated using the spectrophotometric characteristics. And the spectrophotoscopy is in the ultraviolet and the visible ranges is widely used for the characterization of the DOC concentration. Absorbance ratios of E to E3 and E to E6, where E represents the wavelength actually. So E to E3, E4, E6, and SUVA, I will explain it a little bit later. SUVA, these are the 3 spectrophotometric characteristics that's been widely used to investigate the DOC chemistry. A high value of E2, E3 is indicative of the lower aromaticity or the lower molecular rates of the DOC present in the pore water. So here, in case like the DOC concentration at the SKEG, the E2, E3 ratio is lower at the treatments compared to their natural control hummock hollow mean. In case of iPad, is also supporting our DOC concentration results, and at age 38, this is also in line with our DOC concentration results here. None of the treatments is different from their natural surroundings. So, and again, the other thing, E2, E3, if we look at that in the SKEG, the E2, E3 ratio is really high in the natural ones. It means there is a fresh substrate which is of lower molecular weight and lower aromaticity. But in case of the treatments which have been manipulated a lot, that's the reason there's an old organ DOC, which releases humic substances of aromatic nature. Next, please. Next, the DOC quality characteristics, spectrophotometric characteristics is E4, E6, wavelengths ratio, and here, likewise that of the DOC and E2, E3, here at the E4, E6, we got the supporting results for SKEG. We see that the E4, E6 is interpreted as if the E4, E6 ratio is higher than 5 or 6. It means there are the substances or the organic molecules which are of lower molecular weight. But if it is lower than 4, it means it's more of an aromatic nature. So in case of SKEG, we see it's more of aromatic nature organic compounds in the pore water compared to their natural control. And in case of H38, we see they are not different from their natural control. So even in the natural one, we see the aromatic nature organic compounds, since it's also there could have been while taking the samples, there could have been larger roots or the older organic compounds which could have been sampled in the sample core soil sample. Compared to the treatments, here we see a little bit of a higher E4, E6, which actually it's a mix of the two. So some of them, they are of aromatic nature, some are more of a fulvic acids. Next, please. It's a SUVA, specific ultraviolet absorbance at 254 nanometers. At the SKEG part, they are not different from the natural surroundings. From the natural surroundings, since there's the mean comes different from the natural surrounding, while in H38 and iPad, they're not different from the natural. So in the so please go ahead. The next slide. So we have now described the concentration quality of the DOC as a ecosystem function after the restoration of well to the original wetland trajectory. I would invite Rohit to please quickly go through these 2 to 3 slides. Thank you. Hello, Rohit, are you there?
Hello.
Yeah, please go ahead.
Yeah, thank you, Dr. Tariq. Now we have other parameters other than dissolved organic carbon and soil respiration. These are pH and EC. Looking at the results, we found significant differences were obtained in pH values at the SKEG and S38. At IPAD, mixed inversion shows lowest pH. Here, hello, followed by
Yeah, we
clay
will listen.
and peat inversion. Also, natural sites at SKEG and S38 were slightly acidic as compared to the treatment. But when looking at electrical conductivity, we found a large difference in EC at SKEG treatments with any other site and the natural sites where the EC values were very low, while there was no such large differences are obtained at S38. The treatments and natural sites were significantly varying at S38, but not such huge variations were obtained as the other sites and treatments. Now we come to loss and ignition in bulk density. Patterns were similar in the two cases, but the results were opposite. Significantly different LOI values were found at SKEG and S38 both, with undisturbed site showing highest values at both the sites for LOI and for lowest for the bulk and density. So here we can see at undisturbed sites of SKEG at IPAD and undisturbed site of S38, the values are pretty similar and they are much more as compared to the treatments of both S38 and SKEG. While in case of bulk density, thing is opposite. Undisturbed sites at both the sites at S38 and undisturbed sites of SKEG, they are pretty low and they are comparable to IPAD. Now, based on these parameters, the correlation was figured out with soil respiration. So, no significant correlation between studied parameters was obtained at the SKEG and IPAD, which may suggest that respiration is found to be treatment dependent. While significant negative correlations of soil respiration with pH and EC at S38, which is also similar with some other studies done, suggests soil respiration is also affected by the two parameters besides the site conditions.
Well, thank you. Let's conclude the presentation. Next, please. Here are our findings of the research. There were no significant differences between the treatments when compared with the control, and we found SKEG and IPAD individual pads where there were no significant differences compared with the control. And we suggest that the two restored well pads are on the peatland trajectories. Opposite to this, at H38, there were differences of the treatments with that of the control surroundings. So this well pad need to be further monitored in the long run. The third is DOC concentration and quality. With the H38, they were not different from that at the surrounding control. Therefore, there could not be enough accumulation at this well pad to be comparable with the surrounding control emissions or the respiration. The concentration and quality were not different at the SKEG and IPAD sites. And lastly, significant negative correlation was also observed at H38. That was between respiration and all other parameters that were investigated. It suggests that their role in soil respiration rate. No such correlations were found at the SKEG and IPAD. And however, it needs more research and investigation, as this was short-term research with a limited scope. We plan to investigate further in the following years. Thank you so much, everybody, for listening to this presentation. And I would invite any questions. Thank you.
Thank you very much, Arohi, and thank you very much, Tariq. This is Lewis, and we do have time for a few questions. Normally, we go for an hour and then plan on about 45 minutes worth of presentation and 15 of questions. And we do have a few that have come in. For one, I have a question of, can you speak to any differences between dry and wet willow sites with regard to respiration and greenhouse gas emissions?
Yeah, if we go to, let me go to the presentation there. Here. So at the dry and we see at the wet there are a little more respiration, higher respiration rates compared to the dry one, but they're not significantly different anyway. The little higher trend is due to the more accumulation or the production, and also the more growth of the vegetation there. So in total, accumulation plus anaerobic and aerobic respiration together, all they appear a little more which respiration than the dry part, and however it's not statistically different. So we need to look at and monitor it further in the following years.
Thank you. I have one here that has been submitted. Why is a fen higher in pH than that of a bog? And what is the cause of the acidity in the bog system?
Okay, I'll answer the question.
Okay.
Yeah, fens are basically they are higher in pH as compared to bogs. This is based on their formation. This is basically how they are described. Fens are the ones they are fed by precipitation and both surface water and groundwater, while the bogs are the one which are the ambrogenous wetlands we call them, and they are only fed by precipitation. So in case of fen, they are fed by groundwater, which is rich in bicarbonate and calcium calcium and bicarbonate ions, and which acts as a buffer and thus increases the pH. Now come to the second part. What was that? The acidity in the bog system. So we can say acidity in the peatland is a byproduct of microbial decay processes, cation exchange, and input of acids from the atmosphere. So in case of when we talk about microbial decay, bacteria and fungi act and they break down the dead plant annual material and acid is released. But when we come to the second one, the cation exchange, where sphagnum is abundant, it acidifies its surroundings with cation exchange, like it absorbs calcium and magnesium from soil water and gives H+ and makes it acidic.
Thank you. Thank you, Arohi. I was kind of curious about some of the process that, involved with the actual extraction, well, the construction of the site, because I noticed that some of the materials used as a base were clays, and that's usually, when I think of construction of of a highway, of a building or whatever, clays are really not the best materials. Is that because, is it just because that's mostly what's available? There's not much sandy mineral soil available at these sites?
Yeah, that's a very good question. Thank you, Luis. Basically, there are a couple of reasons for they use mostly the clay material here. Usually, the clay used, as far as I know, is kind of a one-to-one type clay so that they don't swell and provide stability to the equipment to work on the well pad. So, in the second is like when they like conduct the boring and so if there is they use the other material like that of a gravel and this kind of those things, so probably they will they might cause breakage and some damage to the equipment they are using for drilling, for extraction. uh, although I'm not a kind of a geologist, but I'm trying to like answer this question. Anyway, this was really good to know, and I will further investigate on it. Well,
Okay. Well, thank you. Um, the I think it's really a good thing, that
yeah,
I guess this whole extraction, uh, of geologic hydrocarbons is the techniques used are scrutinized uh, by by the environmentalists in here where I live, and it's everything is fracking, you know what I mean?
yeah,
And so it's really nice to see that the companies are so involved with the science and restoration. And I don't think enough of this is really it gets out there and is I guess publicized as much. You get a lot of bad publicity with extraction, and I know I guess this is more of a thermal extraction that's done for oil sands, but still, it's this is a wonderful presentation, and I've learned so much.
that
Uh,
was really good explanation, a better explanation actually for the thing. Now I got it. Thank you so much for that.
um, I think we're pretty much out of time, and I just would like to bring everyone's attention to Arohi's and Tariq's emails on this particular slide. If you have any questions that that come to mind or have that could not be answered, please contact either of them. You can get this. Of course, this slide is on the handouts. Um, Thank you very much, both Arohi and Tariq. And I'd like to bring everyone's attention to the Latin American Conference webinars that are conducted in Spanish for our friends in Latin America. And the next will
Okay,
be April 24th. And you can
cool.
find the announcement on the Society of Wetland Scientists website.
I'll keep an eye on it.
Thank you. And then, of course, in um, May, we will not have a webinar, the normal or the regular series, but we'll be back in June with Andy Sharp from East Coast Aquatics and on peatland restoration in Briar Island. So,
That would be interesting actually.
and we love these peatlands.
Yeah, I do.
With that, um, I'd like to thank everyone for attending, and please have a great afternoon. And once again, Tariq and Arohi, this is awesome. Thanks again. Oh, and you will.
Thank you, Louis.
Okay. You will be publishing this work too, correct?
Exactly. We will. It's going to be, it's really, I would say, original and novel research, probably in geosciences or global change biology, kind of a peer-reviewed journal of high repute. We'll do that, and
Great.
we'll also well, thank you very much for conducting all the presentation.
Thank you again. All right.